Graph f of x equals 3 to the x and g of x equals log base 3 of x in the same rectangular coordinate system. Use the graphs to determine each function's domain and range. Well, for f of x equals 3 to the x, I can substitute the exponents in for x to find 3 points to plot. When x is -1, I have 3 to the -1, which is the same as 1 over 3. When x is 0, I have 3 to the 0, which is just 1. And when x is 1, I have 3 to the 1, which is 3. So for the first graph, I have the point -1, positive 1/3, 0, positive 1, and 1, positive 3, which tells me this exponential function goes up to the right, which means it approaches the x-axis as a horizontal asymptote to the left. So that would be my function f. Looking at the function g now, I've got log base 3 of x. So if I substitute these in for y instead, this is equivalent to 3 to the y equals x. So I can say 3 to the -1 is 1/3, 3 to the 0 is 1, and 3 to the first power is 3. So that I can evaluate 3 points that way. So when x is 1/3, y is -1. When x is 1, y is 0. And when x is 3, y is 1, to giving me my 3 points. And for a logarithm, that means that I'm going up and out to the right, which means I'm approaching the y-axis going down as my vertical asymptote, and this would be my function g. For the domain of f, I can see I go infinitely to the left and infinitely to the right. So my domain is all real numbers, which is -infinity to +infinity. But my range starts at the x-axis and only goes up, and so therefore I only have a positive range, and it never reaches the x-axis, so 0 is not included, so the range are just positive values from 0 to infinity. For g, for the domain, I never go to the left of y, so I start at 0 and go infinitely to the right for my domain in terms of x. So that would be just positive from 0 to infinity for the domain. While the range, going up and down along y, I go infinitely down, and eventually this could go infinitely up as well. So my range for function g will be -infinity to +infinity, or all real numbers.